Hey, what's up everybody? So today's lesson is going to be about chops and how to animate for music. So let's start with a very simple concept, which is the sample rate. So the sample rate is simply the channel resolution. So let's go back to Houdini. I'll create a new chop network, and the thing we're going to do is very simply create some animation and import that into the chop network. So let's add a keyframe here, move some frames ahead, do a very simple quick animation to have this. So how to bring that into chops? Inside the chop network you can drop down a fetch parameters node, so we can pick the box node, and the channels you want to import, you can set them here. Asterisk star is going to import like all the channels, but we really just want the translation for now. So let's type T and between brackets X, Y, and Z. So TX, TY, and TZ parameters. So to visualize that, we can open a motion effects view, and to do that I'm going to hit Alt and closing square brackets. It's going to open new pane down here, and I'm going to set that to a motion effects view. So we can click visualize here, and those are the three channels we have just imported. So the sample rate is you're defining here. So if you hit D on this motion effects view, you can see the dots or divisions on the curves, and this is basically your resolution, right? So you can import with more or less dots. So this is one thing I wanted to show you. And well, a very basic lesson on chops. Let's say you want to invert those channels. So let's create a new box here. So for this one I'm going to remove all animation by holding Ctrl Shift and left clicking the parameter. So let's also give it a color so it's easier to visualize. So what we have right now is those two cubes, one animated. So we are going to drive the second box with the channels from the first box. So to do that, we can, let's say we want to like reverse the curves or invert the values. So you can add a math node and go to the add tab here and multiply by -1. So if we visualize now this, we see that we are inverting the values. And well, in chops you can visualize multiple nodes at once. So if you just left click the nodes, you can see them all together. Or if you want to visualize one at a time, you can hold Ctrl and left click, so you can just swap between the nodes, right? So now that you have inverted the curves, we can drive the second box, and you have multiple ways to do that. Very simple. Like the simplest one I found is to go to the common tab and change the export prefix. So because we have the channels with the same name, so TX, TY, and TZ on the two boxes, we can just go ahead and change the export prefix, so that information now goes to box number 2. And if you go to your object network and check the box here, and also make sure you have this export flag checked, otherwise it won't export values. So you can see here now we have this yellow square here, and this is telling us that it is overridden by a chop network. So as you can see here, now if we play, you see the values are mirrored, and we are driving the red box with values from the white box. Okay, so this is a very basic introduction to chops, and now let's see how we can import files and what there is to know about music that you need to know before working with chops. Alright, so audio in chops, you can either use MIDI files or waveforms, which are raw, like waveform data. For this first lesson, we are going to see how to use waveforms, which usually you are going to be opening MP3 files or WAV files. Houdini has support for other file formats also, but those are more commonly used. So these files usually are sampled at 44.1 kilohertz. So that means like this thing here is the resolution is almost the same thing as the sample rate. So it can also be mono, which means a single channel, or stereo, dual channel, so left and right ears. And well, for hertz, this it's like a measure of frequencies. It's a name that we gave to when you want to measure the amount of something, so some data per second. Okay, so it's a frequency measure. For example, when you have a wave that vibrates at 10 hertz, it has 10 full oscillations per second. So hertz is when you refer to this amount of something per second. The sample rate can be the same thing as hertz when the sample rate is defined in seconds, because in shops you can define that like this kind of divisions. You can define per second or per frame or per sample. You have many ways to define that, but when you work with seconds, then you can see that sample rate is the same thing as hertz. And well, I like to use hertz many of the times, because when you talk about music, you are referring to like hertz. You measure in hertz, like the audio quality. So that's the reason I bring that up to you. Okay, so let's go back to Houdini now. Let's start fresh here, empty scene. So what I'm going to do is in chops, create a new chop network, or actually let's go to the object network. I like to create everything in here. So let's dive inside and let's create a file node. So this is going to bring up some audio here. So you can see we have all like these file formats. Some of them are for music, some of them are for the internal file formats Houdini exports stuff, but you can try the file format. So let's go to this project here, audio folder, and we have this very nice remix version from Herbie Hancock, Ready or Not, which is a very nice song. So let's open that and let's visualize in here. So right now, if you middle click, you can see the samples per second here. So 44,100, and that is exactly the CD quality, which is this value here. So 44.1 kilohertz. So, and we also have two channels. So this is a stereo file. So we have left and right ears. Right, so we can also turn on the time bar here, so you can see where the time is. And well, audio by default is very high resolution, so you can hit D and go very close, and you see the dots. So yes, audio is very heavy. So we have to do all sorts of optimizations to work with audio. So yeah, that's how you import and how you inspect audio in Houdini. So middle click is always your friend, so be sure to check your data before continuing. Chain 0 is left ear, chain 1 is right ear. So those channel names are just default names. You can rename those if need be, but yeah, this is how you basically import and check your audio files in Houdini. Okay, so first thing we're going to do now is to check our sound. So to do that, I always like to create a new node here, and let's name that play and give it a nice black color. So in chops, you can always open the audio panel, Alt Y, or this little icon here, and on the scrub tab here, you can set your chop file to play in real time. So you can select a node. Let's select our play node here, and you can hit play. And also be sure to check this real-time toggle here, otherwise it won't play nicely. So let's here. Okay, so I'll give myself a little bit more room here, so 500 frames. So now that we have that playing, the first thing I'm going to do is start optimizing that, because well, we have a lot of information here. We don't need that much information to extract. For example, in this example here, we are going to extract the beats. So we don't need that much information. That's going to only slow down our processes here. So what I want to do is to first, because we have two channels, We just want to work on the first channel. We don't need both. We don't need stereo for this. So let's drop down on the lead node and let's get rid of channel 1. Sorry, channel 1. And we just have channel 0 now. So, and you can, well, let's go control click the first node, and you can see we have 2 channels. If you really zoom in, we can see those are colored slightly different. So we have this cyan and this green one, so channel 0 and channel 1. So when we delete one, we're just working with channel 0. And the other thing I want to do is to resample, because right now, if you remember, 44.1 hertz or kilohertz. So we want to resample that much lower. I find usually working with 10 kilohertz or 10,000 hertz or 10,000 samples per second in this case. It's usually give you like a song that you can work with. It's less resolution, but whatever, it can just extract data like you'd extract with more data, okay, with more samples. So let's hear the difference. So if you play now, so this is full 44.1 kilohertz. If we check the resampled version, you see it's not much different. We can start really perceiving the quality loss if you go lower, let's say 2000. You can see it loses quality. 500 now is very poor quality, and well, the audio has different frequencies. So let's play something here very quick here. So I'm going to create a new channel in an oscillator. So this is basically just well, channel node is emitting like a constant signal, and the oscillator is getting that value and vibrating some waves at the defined frequency. So here we have the base frequency. So this frequency is not the same as resolution, right? So we have 2 things that you can measure with frequency. We have the channel resolution, which is defined by the sample rate. So let's say this one we're going to use 10 kilohertz. And let's really zoom in to see the waves. And you also have the frequency for the oscillations themselves. So this is vibrating at 440 hertz. So you can see if we lower that value, we are creating less of those oscillations, and more is more oscillations. So this is like frequency. When you refer to audio, you're referring to the number of oscillations. When you refer to the amount of data, then it's the sample rate here. So the 2 concepts uses the same unit of measure, but they are really different things, right? So if we send that to our playback, and let's down the volume a bit because it's going to be loud. So you hear this is like high frequency pitch. We can lower those, and you have lower like bass sound. The difference when you are optimizing for high and low pitches is that because high pitches demands more resolution, because you need like more waves, right? So the first thing you lose when you resample any audio file is the high pitches. So because we are just hearing at the beginning here, we're just hearing the bass, so kicks and snares, then it's difficult for us to perceive the quality loss when we resample this audio. So that's one thing to keep in mind. Okay, so let's go back to 10 kilohertz here. And now what I want to do is to extract the kicks, right? So again, let's check the sound. So let's try and extract the kick. So for that, we basically want to isolate frequencies, right? So because audio has different frequencies, the kick is going to be more to the bass or to the lower frequency range. So we have many tools to extract the frequencies. One of them is in the audio category here. We have the parametric equalizer. So the way that works is you have the center frequency and a bandwidth. So it's like we are slicing the frequencies and getting just a little bit of around that frequency we define as the center frequency. So let's hear that. And I'm also going to control click the play so you only see what is the last note here. So, and it's also going to play this filtered frequency. So let's hear. And let me up the volume. So you can see now if we move the frequency around, let me try to up the volume. So you can see we are isolating different parts of this audio, right? So let's say my kick frequency lies around 120 hertz, and you can really see by the peaks here, so the peaks in volume, because we are just extracting some frequency. That means the other frequency are getting their volumes lowered, so we only see the peaks for the frequency we are extracting at the moment. And you can like get smaller bandwidths here. Okay, so let's say our kick stays at the 120 hertz frequency. Let's say we have our snare or whatever is that second sound we hear. Okay, so let's try and extract those two. So let's give it another color so we can really see what's going on here. It's okay, it's blue, it's nice. So we can try and up the frequency a little bit, and there you go, probably around 300 or something. Now you can see we have the blue peaks in between those kicks, and it's actually exactly the second part of the drum set we want to extract. Okay, so let's try and visualize that in a animation so you can see how that works. Okay, so I'm going to create a node here. So this is going to be our kick, and this is going to be our snare. I'm not sure if that's a snare, but anyway, it's just for separating the two signals. And what you have here is a channel named Chan 0 and Chan 0. So I want to really rename those channels just to have something more useful for us. So this is going to be called kick, and this one will be snare. Very nice. So now let's go back to our object network here, and let's create two boxes. So this one will be the kick, and then the second one will be for snare, and we're going to transform the scale for those two boxes so that they vibrate in sync with the beats. Okay, so for the kick, and let me color that real quick. Sorry, not this one. So this one is going to be red, and the other one will be a blue box, like so. Okay, so well, how can we access the values from the chop network? So for this we can use the chop function. You can use the chop function in HScript or in Vex. So in HScript it's like this, so chop, and the channel we want to query. And for the channel, let's go to the chop net and just copy, Ctrl+C on the node and Ctrl+V here. But there's one extra thing you need to do, which is provide the channel name, because we can have multiple channels for like a single node, as we have in here. So I have two channels for this one node. So we have to go not only for the node but also for the channel name. So in this case, the channel name is also kick. So let's go back there and create one more / and then the channel name. Okay, so if we play now, you can see this is, well, let's add some value so that it's never 0. So let's add 1 to that. And there you go. So you see that vibrates with the kick. And let's do the same for the snare. So I'm going to copy that and paste it in here and change the names. So there you go. Now they are both like moving to the music, but you can see they are like vibrating. They are not like really getting the timing correctly. They are kind of hitting at the same time, but they are like vibrating before and after the exact moment of the beat. So what you can do to fix that? So because audio is like this waveform, is not like on and off, we need a way to like extract the exact moment where the beat, where the kick is happening. So to do this, I like to use, for example, an envelope. So envelope node. So the envelope is going to try and detect your hills and valleys. So you can see here, it really, as the name says, it envelopes your curves. And then you can define some, first the type, which I like to go to the local maximum window. And now let's zoom out a little bit. And what you can do now is define your width. So what that will do is to try and really like try and get like small window of time to envelope your waveforms. So with that we can we can create a new node, which is a counter. So you can see we are the thing we're trying to do is to get like a single up and down beat at the highest value here. So you see the first thing we had is was the waveform, and then with the envelope node we were able to extract like reduce the resolution, if you will, just like getting most part like in not in vibrations, but at high and low beat values. And the next one I'm going to do is use the count node. So the count is going to count how many times you go from 0 to 1, or from 1 to 0, that you can define. So this is basically a way to count how many peaks we have here, okay? And we want to define a threshold. So this threshold is going to look only for this highest. If we visualize these envelopes as buildings, the count node, we can define a threshold so that only the highest buildings get a value, okay? So let's try and do that. So there you go. So you can see this count is the yellow thing here. So every time we find like a high building here, it's going to count 1, okay? So there's one yellow or orange building here, it counts 1, and the second big orange building, it counts to 2, and then to 3, and so on and so forth. But that's not what we want. Well, with this you can count how many beats you have on your whole song, but what I want to do is when it goes from 0 to 1, or when it finds a high building here, it counts 1, but when it finds a low, when you go from high to low, it goes back to 0. So we are always in this 0 to 1 range here. So let's fix that by going to the count. So off to on is increasing the count, but on to off is doing none. So what we actually want to do is to decrease the count, okay? And well, there you go. Now we stay at this 0-1 range here, but because our song starts with a high building, we are actually in the -1 to 0 range. So what I want to do is to actually train the song. So let's trim this. And we're going to start, let's set that to frames, and we are going to start at frame 10. So let's visualize that. And also what I want to do is to shift that range so that it starts at frame 1 again. So let's do a shift, set that to absolute and start at 0. So that's going to throw all the song back to start at frame number 1 again. And now we do the same thing, and let's visualize our counter. So now we stay in the 0 to 1 range, and every time we have a kick, it's going to go up, and every time the kick ends, it goes down. So let's, instead of using this kick, let's use, so you see the difference? This one is a waveform, this one is an on-off trigger. Okay, so let's use that instead. And we might want to move that a little bit to the side so that this very high value here, it stays in sync with the high point here on the waveform. So let's do a time shift. So let's move a few frames ahead. So we can, relative to current frame, let's go, I don't know, maybe, sorry, it's not time shift, it's shift. And let's go some frames, let's visualize that, not that much. Well, it's set to seconds, but let's set to frames. So let's zero that. And let's go maybe like so. So the idea is that our tallest point here is in sync with that, with the curves here. Okay, so maybe a little bit less, 0.2. That's good. So let's use that and see how what is the difference between using that and using the waveform itself. So let's play. And here you can see this one is like an on-off state, while this one is like vibrating. And you can do the same for the snare. So let's just copy and paste here. Right, so I'll organize this a little bit, so let's do like that. And also my out nodes will be colored green. Okay, and there you go. So this one, let's give it a new color, and there you go. So now you see down below the, or actually let's do the same colors as we have for the boxes. There you go. So you see we have the kicks in red and the snares in blue, and let's play. And that is how you can extract beats from the music. So now that we have that, we can go crazy with the idea. So for example, we can emit particles from the kicks. Let's do a simple example. So let me hide those and create a new geometry container. Let's call that particles, and let's dive inside, create a new sphere, for example, and let's use a pop network to emit some particles. So what you want to do is to drive the emission by using that chop value. Okay, so we can do that by going to the birth tab here, and let's use maybe the impulse activation. So let's give it, I don't know, like 2000 particles. And for the impulse, we're going to again use that chop function. And let's go to the chop network, copy, Ctrl C on the node, go back to there, and Ctrl V. Don't forget your channel name, so /kick. And let's also, just to make things more interesting, let's add some velocity. So this sphere is going to be a polygon type sphere, and let's just create a very simple attribute Rango to define v as the normal. Okay, providing we have some normals on the sphere. So we're just creating a velocity attribute that goes with the normals. Okay, so we have normal, and the normal needs to be set at the point, and here the Rango is defining the velocity. Okay, so if you go to our pop network, let's play now. And you can see they are, let's do a pop force, and let's create a new gravity with just a little bit of noise. And you can see you can create very nice stuff here. So let's add a little bit more of velocity. So let's inherit more velocity from the emission. And let's do one thing. So let's emit particles for the kick that go to the left side, and the drum goes to the right side. Okay, so let's create a sphere. So actually the velocity, let's add a new vector to that. So let's point to the left side, so -1 in x, and that's going to be, yeah, so this is the kick. And well, we could do in the same pop net, but just for so that is easier, let's do another 3, and that one is for the snare. So let's move that to the right side, and if we merge both, so just let's make sure we just get the pop object from this pop net. Let's color you know what, let's color by velocity, so ramp from attribute, and we're going to use v. Same for the other one. Let's visualize what we have here, but before, let's just change the script here so that it points to the snare and not the kick. Well, it now starts to becoming a little bit heavy. Let's probably emit a little bit less particles, so let's make, instead of 2000, let's make 500. And I'm also going to up my point size here in the viewport to 6 or something. And let's visualize again. Very nice. So what else can we do here? Well, the velocity doesn't seem to be working because it's in the 0 to 1 range. Oh, now that is okay, it's working. Let's also give a create a dark background. And what can you do is to, again, we can always try to do some interesting stuff here. Maybe let's say we want just 50 particles for each one. And what I also want to do is to create a line. So let's add based on the ID. So by group, by ID attribute, let's use ID to add lines. So what I want to do is now create some trails, right? So that we can use to add to create the lines. And there you go. Maybe you want the trail length to be a little bit bigger, and Yeah, very nice. So let's use that also for this one. And finally, let's give them like a short life so that we don't have as many particles on the screen and you can be more performant. So let's say life expectancy is 0.2. I have to experiment with those values, but anyway, let's set that to 0.2. This is in seconds, by the way. It's 0.2 seconds. And let's check what are the results. Okay, let's give it a little bit more life, maybe 1 second, it's good. And maybe we should do less trails so that it's faster. Yeah, so you can see it's very easy to animate once you have all like your frequencies extracted. It is now down to creativity, so you can experiment with many stuff. You can like drive simulations, drive smoke solvers, drive flip fluids, drive rigid bodies, and do a lot of cool stuff. So yeah, that's how I basically use chops to animate in sync with music. So this is one example, is extracting like a defined range, defined frequencies, but you can use that same principles to extract, for example, instruments. Let's say you have a violin play, you can extract the high pitch or the violin. Just remember, when you are in the optimization phase, if you are resampling your channels, be sure to not lose the thing you want to extract. For example, if we're extracting like a woman singing, like vocals, they can be often on the high pitch range. So you have to be more careful when optimizing or resampling your audio channel. Okay. Yeah, so in the next videos I'm going to give you more examples, like how to create other types of visualizers, and I hope you like this one, and until the next one, take care and bye bye.